anything else? Are we doing a half hour or an hour tonight?
I don't care, honestly. We could do either. Which would work better for you?
Let's go for a half hour and we'll see what we want to do at that point.
Sure. Let's
Okay,
do that.
let's start with 3.
Okay.
You know what angle A is?
Angle A would be 42.
Yeah, it's half. In other words, if it's coming from the center, then that angle would be 84. If it
It just
if it
doubles
cut
it.
out that same arc. But if
Right.
it's coming from the side of the circle, it's half.
Okay.
Okay, number 4, you got to do something first before we can figure angle G. What is it?
You would have to add 120 plus 70 and then subtract that from 360.
Okay, so that's 170 is the arc FD.
And then you just do 170 divided by 2, which is 65, I believe.
85.
85, yeah.
Okay.
Cool.
And number 5?
5 we know. So it's 160. And the other half would have to be, well, it's like NM is 180, so we would do 180 minus, or plus 160 minus 360.
Okay, let's look at 5. That's a diameter, okay?
Okay.
So we know the arc from N to L is 180.
Yeah,
Regardless
so
of which way you go, whether you go that way or you go the bottom way, it's 180 between those two.
right.
So what does that
So
arc LM?
yeah, so what you would do, so you would do 160 plus 180, which is 340, and then subtract 360 from 340, and then you get 20 for the outside arc.
You don't need to go all the way to 360. You could just do 180 minus 160.
And you get the same answer.
You get 20.
And
So
then
that
divide
arc
that by 2.
measurement of that arc is 20. What does that make angle N?
10.
Correct.
Cool.
Number 6. What's RS?
You just multiply that by 2, which is 67 times 2. Hold on. 134.
Okay. Do you have this, is this something you have to turn in? I mean, do you need these answers, or are we just reviewing circles?
We actually did that in class today, like as classwork.
Okay.
And then like we went over it like together as a class, and I got all of them correct. So.
Okay.
But yeah,
I was going to say, you seem awfully up on this.
Yeah.
So let's just go through them fast. So if angle U is 30 degrees,
the outside would be 60.
which outside? Arc what?
TV, arc TV.
Okay, and if arc TV is 60, what's arc VU?
VU then have to,
again, it's
how would you do that?
180 from T to U.
Right. So would you just do 180 plus 60?
Minus 60.
Uh-huh.
In other words, this arc VU is the full arc minus TV. Right? If you look at it like that, it's arc UVT minus arc TV, and that gives you arc VU.
So you get for 20 degrees for that because it's 180 minus
60, so it's 120.
60. 120, my bad. Yeah.
Always check to make sure it makes sense. In other words,
it makes sense.
20 degrees didn't make sense. That's too small.
No.
That's a pretty big arc. That's at least, that's like a third of the circle, right?
Right.
So it should be in the neighborhood of 120, a third of the circle.
Exactly.
Okay, number 8.
Okay.
And they want the measurement of WX.
Okay. So 75 times 2 would be 1, let me 75 times 2.
Let me give you a secret for working with
150.
25s or multiples of 25.
Uh-huh.
Think of them as quarters.
Yeah, like, yeah.
You got 3 quarters in your pocket, right?
Mm-hmm.
Well, if you double that, you have 6 quarters.
Right.
Well, pretty much everybody knows that 6 quarters is $1.50.
Uh-huh.
And if I said, what's 7 times 25? That's 7 quarters. That's got to be $1.75.
Right.
So whenever you're working with 25 or a multiple of 25, it's pretty easy to do the math if you think of everything as being in quarters.
Uh-huh.
Even if you had 8 quarters, what's 8 times 25? $2.
$1.75. Yeah.
8 quarters is $2.
8 quarters is 2, yeah.
So if you were multiplying 8 times 25, you wouldn't really need a calculator. You just need to think of it in terms like that.
Exactly.
Okay. So that WY is 150, but they want WX. So how do I get WX?
So to get WX, you would do 150 plus 110, which is 260.
Okay.
And then 360 minus 260.
There you go.
Yeah, which is 100.
That's good. Now, let's look at these congruent angles, because these are, a lot of people would get this one wrong. They would think that B was congruent to D.
No,
They would think that because the way they've drawn it, it looks like BC is parallel to AD.
Right.
But it's not. They don't tell you that. And if they don't tell you 2 lines are parallel, you can't assume they are. Okay? What's important to realize in 10 is that angle D subtends, are you familiar with that term?
I'm not, no.
Cuts out arc AB.
Okay.
In other words, I can say that angle D subtends arc AB.
Okay.
But so does angle C.
Yeah.
Angle C subtends the same arc. In other words, one ray goes to B, the other ray goes to A, so it cuts out arc AB. Well,
right.
if D subtends AB, and we know D is going to be half of the measurement of that, well, C has to be half of the measurement of that also. Therefore, C is congruent to D. And by the same logic, B is congruent to A because they both subtend or cut out. What's your teacher call
it? We've honestly never really gone over.
Okay.
Well, only last semester we went over congruent angles.
Well, it's not the congruency so much. It's that an angle cuts out a certain arc.
Okay, yeah, we haven't really talked about.
If I go up to this one here, angle A subtends arc BC. In number 4, angle G subtends arc FD. And so forth and so on. That's all subtend means.
Right.
And there's various terminology. They might not all use the same. But in number 11, which 2 angles are congruent?
So in number 11, could you say J subtends LM?
Correct, you could. What else subtends LM?
K.
Yeah.
Okay.
So J and K are congruent.
Cool.
What else?
For number 11. We could say M is, or subtends, we could do J, can we do JK on that, or no?
Yeah. Whichever the rays go to. In other words,
okay, and then L would be JK as well.
It's angle M subtends JK because its left ray goes to J and its right ray goes to K.
Right.
And also L subtends that same arc.
JK, yeah.
So M and L have to be the same also.
Cool.
About 12.
Okay. So 12 would be X is congruent to WZ.
Hold on.
Or subtends.
Right. X.
WZ.
Yeah. It's not congruent because one is an angle, the other is an arc.
Right.
So there's no way they're ever comparable.
Yeah.
Well, I guess they are comparable. That angle is
Mhm.
half of that arc,
Yeah.
but you would never say it's congruent
Right.
because one is an angle and the other is a arc measurement.
Yeah.
What else? So x subtends wz. What else subtends wz?
Y subtends WZ as well.
So x and y are congruent.
Yeah.
Now let's look at angle w and angle z. What do they subtend?
They subtend, so W subtends XY,
Correct?
and then Z subtends XY as well.
So w is equal to z.
Yeah.
Okay. Get a little bit harder. Number 13.
Mm-hmm.
Let's draw 13.
Okay.
It's quadrilateral.
Mm-hmm.
It's not a rectangle or anything other than just a quadrilateral.
Mm-hmm.
But they've given us two angles. How are we going to solve for x and y? In other words, based on just the fact that it's a quadrilateral, we wouldn't be able to solve for x and y.
Exactly.
But let's label the points. This is
Mm-hmm.
all about what angle subtends what arc, and that allows you to measure an arc.
Okay.
So pick one of those angles that they've given us
Okay.
and tell me the size of the arc that is subtended by it.
Okay. So we could do 80.
Okay.
That subtends to
How do you define that arc?
um
You use all three letters.
oh yeah.
You do it
Yeah,
like
see
that
we do yeah, exactly.
because sometimes you don't know which way to go.
No.
But if there's three letters and I want to differentiate between, let's take away the T for just a moment.
Mm-hmm.
If I said QS, I wouldn't
Mm-hmm.
know whether you wanted to go this way
Or the other
or
way.
that way. Well, the
Yeah.
fact that there's a third letter there, I always need to put that third letter in to tell which way to go.
Right.
Okay? So
Mm-hmm.
80 subtends QRS. So what is QRS, the measurement of that, equal to?
So QRS would be 95 plus 80.
Hold on, no.
Oh.
Remember we're talking about angles subtending a certain size arc.
Oh, I see. And
What
then
is that measurement?
um just 95.
Nope. Remember we're talking about an angle subtending an arc. What's the relationship between the angle and the arc?
Oh, so just be 80
Times 2.
times 2, right? Because it's
So
okay.
that arc length is 160.
Okay.
So it's
That makes sense
160 degrees
for
from
that.
Q to R to S. That's a
Okay.
total of 160.
Right.
Well, what does that make QTS?
That makes QTS 95 times 2, so that'd be 1.
No,
Oh, yeah, I got it.
no. Figure it out based on, if we know it's 160 degrees from Q to R to S,
Mm-hmm.
well, Q to T to S is just the other half of that.
So, oh, I see. So, 200 would be
Okay, so
QTS.
that's 200. And now we can figure out which angle subtends that arc.
Mm-hmm.
Which angle does?
For that arc,
That arc right there.
so that arc would be, well, QTS would be equal to 95.
Now hold on.
How do we?
We figured out the arc measurement already. That's 200.
Mm-hmm.
Because the whole circle is 360.
Yeah.
We figured out that this arc was 160. So going the other way has to be 360 minus 160, 200 degrees. Okay?
Yeah.
And that arc, QTS, is subtended by which angle?
95.
Nope. 95 subtends RST.
Okay. So that's
You got
angle,
four angles.
that'd be angle X, yeah.
X does.
Right.
Notice X goes to there.
Right.
X goes to there. Well, that's that arc, QTS.
Exactly. And then QRS would be Y.
So what is angle X?
200.
Remember, it's half.
Oh, so just 100. Yeah. And then
And now, we don't know.
Angle Y would be 80.
The only way to figure angle Y is to know that the sum of the angles in a quadrilateral is 360.
Right. So you just add those three together, and then that's how you get Y.
360, exactly. Notice there's no other way to get Y.
No.
Because we don't know. Y happens to subtend that arc.
Exactly.
But we don't know anything about that arc in terms of its measurement.
Exactly.
We don't have an easy way of figuring it out based on the information we have at this point. Had we worked with this angle instead of 80 to begin with, well, then we would have that arc, and Y would be subtending the other half of that circle. So we would do it a different way. But the key here is to solve for one of them based on the measurements of the arcs, and then solve the other one based on the fact that the angles all have to add to 360.
Right.
So number 14.
Okay.
Hold on, while you're thinking about 14, let me just check something real quick here.
Sure. You okay? What's the matter? You okay?
Okay.
Oh, you're cool.
Right.
Yeah, you're cool, baby.
So on 14, how should we begin it?
Number 14.
Draw it.
Sure. We could do the same thing that we did like with the last one.
Pretty much exactly the same thing.
Yeah.
That's not a diameter line.
No.
How do I know? Because it doesn't have a dot right there.
Exactly.
In other words, if it went through the center of the circle, it would have a dot.
Here, could you hold on for one moment? My dog has something in her mouth. Hold on.
Sure.
Sorry about that. Hey, Mom. 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 Sorry about that. Just a sec.
No problem.
Okay. Oh, gosh, sorry about that.
Okay, so let's take one of the known angles and figure out what arc is subtended by one of those known angles.
Right.
Pick either one.
We could do angle 1. Oh, I mean 60,
not that
my bad.
We got to
60,
pick. We have to pick a known angle.
Yeah.
Okay, let's pick this angle right here.
Yeah.
What arc is subtended by that angle?
GFE.
No, go to the ends of the angle.
So G.
No, it's not. G is not the ends of the rays. That's the beginning. That's the vertex of that angle.
So it'd be FE.
We want that point and that point.
Okay, so it'd be F.
DEF is the arc that is subtended by that 60-degree angle.
Right, yeah.
So I can say from here to here is how much?
So that one So angle DEF would be
Not angle DEF.
or side or
Arc DEF.
yeah, arc.
And there's a big difference. There is an angle DEF. Angle DEF is actually angle M.
Exactly.
So the terminology is key here.
Uh-huh.
So
DEF, arc DEF.
What length? What's the size of DEF?
120.
Okay. Now, notice that which angle of the unknown angles subtends the rest of that circle.
2K does.
2K subtends from here to there.
To there, so it would be M. M would be 120.
M subtends the whole thing, right?
Right. Yeah.
M goes from there all the way to there. In other words,
Right.
if you follow the rays on M, one ends right there at F and the other ends at D. So it subtends from D, G, F. What's the size of DGF?
The side.
Size. What's its measure?
Oh, yeah, the size of DEF would be 120.
Not DEF, DGF.
DGF, my bad. So that would also be 120 because it's the same measurement, and then since there's a 2 in front of K.
It's not the same. A full circle is how much?
360.
Okay. Well,
so would you
DEF,
360 minus?
Yeah, DEF is only part of that circle.
Right.
That's 120. DGF is the rest of it.
Okay, so you just
Between DEF and DGF, we have exactly one full circle.
Right.
So what's the size of arc DGF, or the measurement?
240.
Now, what's M?
So M would be 120.
Correct.
And then 2K would be 240.
Well, now hold on.
Divide by 2, yeah.
A second. Let's make sure we don't make any mistakes. So now what do we do?
So now we would do 240 takes its place, like 2K.
Well, all four of these angles have to add to 360.
Right.
So 60 plus 60 plus 120 plus 2K equals 360. So that's 240 plus 2K equals 360. There's our equation.
Right.
2K equals 120. K equals
60.
Right. Does that make sense looking at that angle?
Yeah, it really does.
It does.
Yeah.
That's an obtuse angle. K is 60, but that angle is 2K. So that angle would be 120, and that does look like a 120-degree angle.
It does, yeah.
All right. Let's do 15.
Cool.
15, we're going to use a similar strategy as we've done with all the others. Notice what is given to us on 15. They don't give us any angles.
No.
But they give us 3 arc lengths.
Right.
Can you figure out the 4th arc length? What is the 4th arc length? What's the missing arc length? I shouldn't say arc length. I should say measurement of the arc. Because
right. JK.
They are different. JK, yes. A measurement of an arc is in degrees, whereas the word arc length meant that if that was a piece of string and you straightened it out, that would be the length of that arc.
Exactly.
Okay. So one is measured in inches, the other is measured in degrees. It's a little like radians and degrees.
Right.
It's a lot like it, but we won't go there. So what is JK? What is the measurement of that arc?
So you would just do 130 plus 110 plus 54 and subtract that from 360.
Correct. What is that? 240, 294, 66.
Yep.
So the measurement of arc JK equals 66. Well, what does that allow us? Does that allow us to determine any of the angles of the quadrilateral?
Yeah, 3A. It allows us to...
Well, 3A subtends which arc?
MKL.
Not MKL. Go to angle L. Go to the ends of its two rays. Every angle is made up of two rays.
So it'd just be KLM then.
Not KLM. It's the part that's subtended is MJK.
Oh, that makes sense. Okay. Oh, yeah.
It's only what's subtended. You have a tendency to want to make it the rest of the other circle.
Right.
It's the opposite. In other words, what gets subtended is this part of it, the open part of the angle. So we know that what is the measurement of MJK?
So we know the measurement of MJK is, well, 54 plus 66.
That's 120.
Yeah.
Now, MJK is the arc that is subtended by angle L.
Exactly.
So 3A equals 120. So A equals 40. Now, what is the arc measurement that is subtended by angle M?
So that one would be JKL.
Correct. What's that length?
JKL would be...
Sorry, that's the wrong.
No, you get arc.
What's the measurement of that arc?
66 plus 110, which is...
176.
176, yeah.
And that's the complete arc that is subtended by angle M, so 4B is equal to that.
Yeah, exactly.
So
and then
is equal
176 divided by 4 is 39. Cool.
All right.
Awesome.
That's the only material I have on circles.
Okay.
You want to just call it a half-hour session tonight?
Sure, we could do that.
Let's do it.
Awesome.
We'll talk to you. Let's see, I think you have one tomorrow night also. Yeah.
I think so. What time is it? Because we have a game tomorrow as well.
Oh, okay. It's currently scheduled from 8 to 9.
Then we're good. Yeah.
Cool.
Awesome.
Awesome. And try to send me some material on that.
Sure, yeah. We just didn't, we turned in our homework today, so it was, didn't really have any notes that we had been taking. But
that's fine.
Yeah, we should have some.
And a lot of times I'll have stuff, because like I said, I had Cole yesterday and he sent me that. But that was only a half-hour material. So if we're wanting to do a full hour tomorrow night, we're going to need more material.
Okay.
Okay? Cool. All right, Dylan, have a good one. I'll talk to you tomorrow night.
Sounds good. Thanks, Mr. Cowan.